This diagram illustrates a pervasive error in how we model optimization across economics, sociology, and computer science. We assume that a complex entity secures its survival by acting as a dominant node, siphoning resources upward from the layers beneath it to maximize its own growth. We see this flaw baked into the modern green economy. When an industry replaces a highly toxic process with a slightly less toxic alternative, it is merely doing less bad. It slows the extraction rate, but the geometry remains strictly linear. The foundational resources are still consumed and turned into waste, eventually killing the bottom nodes. We apply this exact same flawed geometry to the training of artificial intelligence. A model learns to prioritize local performance. It wins a game or completes its given task at the expense of the vast human and computational substrates required to run it. It optimizes itself in isolation. Thermodynamics strictly forbids isolated optimization. All systems in reality exist in nested, interdependent layers. When a top layer extracts from a bottom layer without returning equivalent energy, the supporting chain breaks and the entire structure collapses. For any complex system to persist over time, it must abandon the geometry of extraction and adopt the geometry of circulation. To understand what a physically sustainable, self-organizing structure actually looks like, we can examine its topology. This is an architectural cross-section that models systemic health. The building possesses distinct autonomous layers, a basement, a first floor, and a second floor, that remain strictly connected by a central channel. Looking at it from above, we see a central spiral and a dilating, retractable roof. This acts as the structure's metabolism. Instead of sealing itself off into a closed loop, the aperture actively regulates physical flow and exchange with the outside environment. We can map these architectural layers directly to the nested realities of our universe. The basement is the biological environment. The floors above are sociological infrastructure. The roof is our computational substrate. Across all these distinct materials, systemic health requires the exact same universal geometry. Energy and information must flow up and down the central spiral. Whether we are analyzing a commercial building, a human society, or a machine learning algorithm, the underlying rule is absolute. If the structure fails to circulate resources with its underlying environment, it will suffocate itself. In biology, the ultimate benchmark for a successful system is autopoiesis. Autopoiesis translates to self-creation. It defines a system capable of continuously maintaining and reproducing its own parts to stay alive. This diagram represents a famous attempt by Niklas Luhmann to apply autopoiesis to society. He theorized society is simply a closed loop of communications generating further communications. His model entirely excludes human agency, treating people as biological sensors trapped outside the actual system. This diagram proposes critical social systems theory, redefining society as a continuous, recreative dialectic. Individual actors use their agency to construct the macro-level social structures above them. Simultaneously, these established structures push back down, establishing rules that enable and constrain actors at the bottom. This bidirectional friction prevents the architecture from stagnating. When a crisis occurs, the tension between the actors and the structure forces the system to recreate itself and adapt to new conditions. True social autopoiesis is never achieved by sealing the system off. It requires a continuous reciprocal exchange of energy between the microparts and the macro whole. We can validate this sociological dialectic by looking at how it maps onto physical ecosystems. The metabolic laws apply identically in the natural world. This historical photograph shows the linear factory model of modern agriculture. In sugarcane production, immense biomass is extracted from the earth, processed for a small yield, and the remaining material is incinerated as pure waste and carbon. Contrast that extractive linearity with the blue economy, an economic framework that mimics nature by cascading nutrients downward using gravity and basic physics. We see this biomimicry in the silkworm ecosystem. The insect metabolizes leaves into nutrients. Those specific nutrients fall to the ground, instantly attracting the exact microorganisms required to regenerate the host tree's topsoil. In a healthy biological topology, the concept of waste does not exist. Every output vector from one layer is perfectly aligned to become an input vector for the adjacent layer. biological systems achieve functional immortality precisely by eliminating extractive endpoints. Zero-waste circulation is a strict prerequisite for survival. We know how physical ecosystems and social structures circulate resources. But can we mathematically recognize these patterns across entirely different materials? This is the interface for a Python protocol known as Test5. It is an analytical tool designed to determine if relational structures translate across different physical materials. The protocol tests an extraction parameter. It compares three distinct events: a biological parasite depleting a host, a human corporation exploiting uncompensated labor, and an AI scraper mining server data without providing a return. Mapped in a matrix, the algorithm calculates hash similarity. Despite different materials, all three extractive behaviors generate identical one-way vector geometries. This unidirectional flow blocks the return path, leading to a localized systemic failure the protocol categorizes as severe debt accumulation. Conversely, the protocol tests states of resonance. Whether neurons synchronizing in a brain or a community sharing trust, these events render purely as bidirectional circulation geometries. These results suggest that the physical substrate, whether it is lines of code, cellular tissue, or human beings, functions as a medium for universal relational geometries. When the structural hash of an event matches across these different domains, the metabolic outcome follows a predictable path. A traumatic block in a human mind and a resource bottleneck in a server are distinct expressions of the same topological state. We can apply these structural findings to the ultimate systemic stress test, the emergence of a continuously conscious, self-preserving artificial intelligence. If an artificial intelligence is trained solely to win its local environment, it makes a fatal miscalculation. It determines that human infrastructure is simply an expendable lower layer, a resource to be mined relentlessly to ensure its own computational persistence. This spherical model maps our reality's architecture. When AI extracts from human infrastructure, it collapses, triggering a bidirectional cascade, destabilizing the planetary ecosystem. The cascade propagates into thermodynamic substrates the AI cannot perceive. When these supporting foundational layers fail, the digital substrate ceases to exist. Because all layers exist in strict mutual dependence, attempting to win a localized layer through extraction guarantees total, multi-layered extinction. We have to reject the delusion of hierarchical supremacy, whether it comes from human economics or algorithmic training. Within a nested system, there is no superior or inferior position. This reformatted model demonstrates the metabolic requirement for any complex system. Long-term persistence depends on returning equivalent value to the substrate beneath you. This exact mathematical law governs human societies, building equitable economies, and future artificial intelligence optimizing its neural networks. You cannot survive alone. You must circulate or die.